The waters off Mozambique's wild coast are home to marine giants. The world's largest and most elusive stingray and the greatest fish in the sea parade along the coast, feeding in its nutrient-rich waters. But even the ocean's largest animals are defenseless against reckless overfishing.
It's an urgent issue, and we need to start making some changes here to save these species.
And you start to realize that if you don't stay and fight for them, no one else is going to.
Now, Mozambique's leading marine researchers set out to find one of the ocean's most secretive animals and protect its most well-known before it's too late. It's a race against time to save the giants of Mozambique. The waters of Mozambique teem with marine life. The Western Indian Ocean pumps nutrients along this coast, inviting some of the ocean's most exotic and most loved marine giants.
It's almost like the perfect storm. It's a situation where the continental shelf drops off really close to the shore here, so it generates a lot of upwelling here, a lot of nutrients being pumped in along the coast. So you just get a lot of biodiversity here, a lot of food here.
A resident population of juvenile whale sharks feeds along the coast, gulping up the plankton-filled water. Migrating humpbacks use the coast's warmer waters to breed. Pods of dolphins skip through the water, chasing after smaller fish that have come close to shore and close to the surface to feed, providing the dolphins with a small feast. A rare giant also makes an appearance as it surfaces on the coast. The mola mola, or ocean sunfish, weighs as much as a bull and is the heaviest known bony fish in the world.
This, to me, is one of the most critical habitats in Africa. I call it the blue heart of the East Coast here, and I really do believe it's one of the last blue wildernesses left in Africa.
The wild coastline of Mozambique stretches along more than 1,600 miles, from Tanzania to South Africa. Andrea came to Mozambique's Tofo Beach to study manta rays in 2002 and never left. She established the Marine Megafauna Foundation, an organization dedicated to the protection and conservation of larger marine species.
I arrived to the most pristine environment I'd ever seen. You could walk on the back of whale sharks here. There was mantas everywhere, turtles everywhere. It was like utopia for me, and especially for a young marine biologist, you couldn't get any better than this.
But things have changed drastically, for the worse.
As I saw things changing, as I saw development happening, and as I saw these fisheries starting to barter for things like shark fin, I realized that what I'm fighting for is I'm fighting for that picture of Mozambique when I first arrived. I just won't be satisfied until we can bring it back to its original splendor.
70 miles down the coast at Zavra Bay, the manta ray population is healthy, and there's little to no impact from recreational diving. But local fishing practices pose a big threat. Nakia Kolain fights to preserve what is for now a pristine coast.
They put out these large nets, and unfortunately, their target is smaller fish, but a lot of other bigger species get trapped in these nets.
A lot of the locals here are self-sustaining. So by fishing, they support themselves and their families.
The problem is, the fishing nets are placed along the shoreline, intercepting the migration route of larger species, such as rays and sharks. Nakia and her partner Mornay run Zavra Marine Lab, a research station established in 2009 to investigate and conserve the coastal ecosystems of Zavra Bay. It's set on one of the most remote stretches of Mozambique's coastline, a place where many of the reefs are yet to be explored.
It's wild, and it brings in a lot of different marine life, so the diversity is amazing. The remoteness and the quaintness of it is fascinating, and it allows for us to do some research that's never been done before.
Nakia hopes to learn more about which reefs the manta rays use most, and in what numbers. This information will help her monitor the population and protect the migration routes of these marine giants from local fisheries. The murky, nutrient-rich water along Mozambique's coast attracts many filter feeders. Among them, the giant oceanic manta ray, a larger cousin to the smaller reef manta, which Andrea first established as a separate species in 2008. It's one of the largest new species discovered in the last 50 years. A lot has been learned about these gentle giants in just a short time.
We've identified more than 1,000 individuals living along this coastline. We've documented a lot about their reproductive ecology. We've learned about their predation. We've learned a lot about population genetics and how these animals are mixing in different parts of the coastline. We really have done some of the keystone work on manta rays.
While researching manta rays, Andrea uncovered another giant, one she's never seen before.
I started noting when we were diving this really large ray that I was completely unfamiliar with. I couldn't even really ID it. It was this crazy mystery, trying to figure out what this animal was. One of our friends who worked in Indonesia eventually helped us ID it as a small-eye stingray, which is a very rare animal that comes up mostly in fisheries around the world, but very few people encounter it alive and very few people have any data on this animal. So we were shocked that, we had such a rare animal living here.
More than 7 feet wide, the small eye is the largest of all stingrays. The ray is named after its small, beady eyes, which leave the animal with poor vision.
We were shocked even more when we found that it has never been seen west of the Maldives. So we actually wrote a paper back then and did a range extension showing that they actually live along the eastern coast of Africa. But then we were tasked with finding out more about this animal, which is really hard when you don't see them very often.
The rays are so rarely sighted, researchers can't begin to guess the size of their population. Andrea's records show sightings peak in September and October. With a short 2-month window ahead of them, she and her assistant, Anna, set out to find and tag the small-eye stingray, one of the ocean's rarest creatures.
They don't distribute evenly. They prefer certain reefs, so we're actually going to target those reefs today.
It's going to be great to try and learn where they're going and what they're eating and where they are when we're not seeing them.
Hopefully, in the same way that we do with manta rays, we can find out how large the population is by taking the ID shots of the spot patterns that they have on their backs. We'd like to be able to start with telemetry, putting some tags on them and finding out how they use the local habitats, how far they travel. So really, the world's largest stingray, we know nothing about it, and that's what we're endeavoring to do, is learn more about this really awesome animal.
The visibility isn't ideal, but Anna and Andrea hope they'll be able to spot the small eye, if they see it. The temperate reefs along Tofo's coastline appear dull and rocky. in stark contrast to the colorful coral reefs of the tropics. The lack of color on this reef makes the researchers' jobs much more difficult, as they try to spot well-camouflaged animals through water clouded by plankton. Many, like this alligator fish, disappear against the rock. As they scour the reef for small eyes, a curious potato bass joins them. It's named for the large potato-sized markings on its body. The potato bass, or potato grouper, can grow to 7 feet. It's one of the largest predators on the reef. Despite their round physique, potato bass are extremely swift hunters. But this one seemed content to just hang out.
There was this potato bass that was, it just wouldn't leave us alone. It was trying to bite my strobe, and everywhere we went, it would seem to be following us.
Potato bass tend to be inquisitive toward divers. As a result, they make easy targets for spear fishermen. Because it's so big, the potato bass is a sought-after trophy fish. Its survival is now threatened by overfishing. Anna grabs a photo ID of the fish, so the team can keep an eye on this friendly giant on future dives. Still, no sign of the mysterious small-eye stingray. There are no rays here at the moment, but the information they've collected over the years indicates this reef is a hotbed for both manta rays and small-eye stingrays. Anna and Andrea deploy a listening station that will record activity on the reef when they're not there to monitor it themselves. The acoustic station picks up pings from tagged manta rays as they pass by. If Anna and Andrea are successful, this listening station will also pick up pings from the first ever tagged small-eye stingray. The equipment is ready. Now the team just needs to find a small-eye stingray to tag. Down the coast at Zavara Marine Lab, Nakia and her team hope to find an ID manta rays at an inshore reef. Andrea's network of acoustic listening stations and her photo database have helped her document more than 1,000 individual mantas at Tofo. Here at Zavara, Nakia and her team have logged fewer than 400 mantas, and there is no network of tags to track the rays.
It would be nice to start some tagging with the mantas so we actually know their migratory patterns and what they're doing. There's a lot of unanswered questions, and I'd love to get to the bottom of it.
The team heads out to find answers. Nakia needs to identify which reefs the manta rays favor so she can install acoustic listening stations to monitor their whereabouts. But working on a wild, remote coast is never easy. Nakia and her team face their first set of challenges before they even get on the water.
Normally what we do is the tractor will pull the boat along the beach, and then when we get to the launch spot, the tractor will launch us into the water, usually with the back first.
But with today's sticky, wet sand and rough seas, this isn't possible. So it's on to Plan B.
They ask us to push, push, push through the waves, over the waves, and then we hop on the boat and we head out.
Nakia and her team continue to battle the elements.
We tend to have a lot of plankton in the water, which in turn leads to bad visibility for us divers. However, it does bring in a lot of our big megafauna. And for us, as we use photo ID for a lot of our surveys, it can be challenging to fight through that visibility and the heavy surge and the swell. So definitely poses challenges, but we continue to go out and sample.
When you go down in this water, yes, the vis is not so beautiful, but you go down and you've got this feeling of it's you, your soul, and the water around you and the creatures around you. When you see animals in their natural habitat, you get a certain amount of respect for an animal.
Before long, Nakia spots one of Zavra Coast's most graceful animals. A reef manta ray appears from the gloom. Soon, several rays circle the team.
We're very, very lucky with our mantas. They're very, very curious. They come extremely close, so it makes it very easy for us to get some nice identification photos.
Nakia takes photos of the spot patterns on the manta ray's belly to ID the animal. She uses a laser to measure its size.
They swim over you, they swim with you. It's breathtaking, and it will never get old, ever. It's wonderful.
The mantas have come here to be cleaned. Mozambique's manta rays form partnerships with 8 different species of cleaner fish. The cleaners remove parasites, mucus, and dead skin from the manta ray's body. Each fish cleans a different area, so they don't compete with each other. But on this reef, the sergeant major damselfish outnumber the other cleaners. The rays can spend as long as 10 hours interacting with the cleaners. Mantas have the largest brain of any fish in the ocean, specifically the regions of the brain responsible for sensory functions, memory, and learning. Behavior in this research footage suggests that manta rays signal to the fish the body parts they want cleaned. They flick the back of their pectoral fins or flare their gills to indicate these areas require immediate attention. On this reef, one manta ray demands more attention than the rest. This female reef manta bears a scar from a shark bite on her pectoral fin. A damselfish follows closely behind her to clean the wound. The ray's bloated stomach shows she's pregnant. She will need to be cautious in these waters.
With the mantas, you do see a lot of predator scars on their pectoral fins. This is usually from bigger shark species. Zambezi sharks, blacktip sharks, a lot of different shark species that could potentially be preying on the mantas. So we do see a lot of the mantas with these big chunks taken out of them.
The manta isn't typically a target for large predators. Nearly 3,000 miles east of Mozambique, the Maldives has one of the world's largest reef manta populations, yet relatively few are attacked there. In an estimated population of more than 5,000 reef manta rays, only 500 exhibit any sign of bite marks or scarring, about 10% of the population. The manta ray's size alone is enough to deter most attackers. But in Mozambican waters, more than 70% of the reef manta rays have visible scars, the direct result of shark attacks.
While we don't always see these large predatory sharks while we're out on our surveys, we tend to see some remnants that they're there.
As Nakia and her team survey the area, they come across an unexpected find. A half-eaten black-tip shark.
It's a little eerie, bad visibility. This looks like it didn't happen too long ago. So you're wondering if these sharks are still looming in the area. I was very curious as to what could have taken half of this shark in a clean swipe.
The size and shape of the bite mark suggests a much larger predatory shark is responsible.
There's no sure way to determine which shark actually did take the chunk out of the blacktip. However, with this nice clean cut and the blacktip was quite big, we're assuming that it was potentially maybe a white shark or a Zambezi, one of these bigger sharks in our area.
Researchers believe that Zambezi sharks are the primary predators in these waters. Also known as bull sharks, these predators are considered to be one of the most dangerous sharks in the world. They're fast, agile, and will eat almost anything. Bull sharks are opportunistic hunters. Though they prefer smaller fish like snapper and mackerel, they will eat what's readily available. Bull sharks have been known to attack rays, dolphins, even other sharks. They prefer to hunt in murky waters, and Mozambique's plankton-fueled coast fits the bill. For this soon-to-be mother, the worst is over. A manta ray's tissue regenerates incredibly fast. With a little help from the damselfish, the wound remains clean and should heal completely in a few weeks. Meanwhile in Tofo, Andrea and Anna continue their search. But there are no small eye rays in sight. Not even a single manta ray. In the distance, Andrea spots a blotched fantail ray, also known as a marble ray, for its distinctive light and dark blotched coloration. These rays are found throughout the Indo-West Pacific in a wide variety of habitats, from reefs to shallow lagoons. The ray moves its disc-like pectoral fin to cruise through the water. The marble ray can grow to 6 feet in width. The blotched fantail ray isn't aggressive, but it's cautious of strangers in the water. The ray assumes a defensive position.
And it's just amazing how you can't really get close to them at all without them starting to posture. The smaller the ray, the more, frightened they are of a large, strange animal.
The ray's stinger sits near the base of its tail and contains a sharp spine with serrated edges that face the body of the fish. Its greatest weapon, a venomous gland, rests at the base of the spine. A membrane-like sheath covers the entire stinging mechanism. Anna approaches carefully to get a photo ID of the stingray. When a ray strikes, its tail shoots up, jamming a stinger into the body of its victim. The pressure from the strike tears the protective sheath. The sharp serrated edges of the spine sink in, and an excruciating venom flows into the wound. If released into a vital organ, the venom can kill a human. These bottom-dwelling hunters often hide in the sand and go unnoticed by divers. If stepped on, the ray's sting usually leaves a wound around the ankle. It's a treatable injury if it's looked after quickly enough. The small-eye stingray is far larger in size, and its tail is much more robust, so it could be more dangerous. But there are no recorded incidents with this rare and elusive animal. Over millennia, the giant oceanic manta ray lost its stinger entirely. Its size alone is enough to keep most predators at bay. A small bump on the back of its tail serves as a reminder of the time this large fish had a stinger. Another day breaks in Tofo, and Andrea and her team get a second chance at finding the small-eye stingray. They prep the research boat as the hunt presses on. But a new challenge lies ahead.
The sea is actually really flattened out today, which is amazing. It's going to be a great ride out there, much flatter. Have a little bit of a tricky launch, even though there's no waves. There's a massive sandbank, so I'm actually going to have to launch sideways, which is pretty strange, and track along the coast and then spin out just around the sandbank. So we'll see how that goes. I don't normally launch like that here, but this sort of sandbank popped up, so we'll see how it goes. Every day is new here, so a little bit of a challenge, but we'll see.
Andrea steers the boat clear of the sandbank, and the team heads out, hopeful that the flatter seas will yield better visibility and allow them to spot the small eye. The visibility is much better today, providing a much clearer view of the sea life. Unfortunately, the better visibility also reveals a disappointing reality. The larger animals just aren't there. Not seeing one of the most rare animals in the ocean, the small eye, isn't surprising. But not seeing manta rays off Tofo's coast is.
So we were chasing the good viz today. I'm guessing maybe all the animals are hiding down in the green water down south. So we're going to brave it tomorrow and try and go all the way south to some of our sort of flagship reefs here. Might be cold, it might be green, but we're still hoping for a lot of animal life. In the last few days, we haven't really seen very many animals, which is kind of rare. How do you hide some of the world's largest fish? Where do they go?
The lack of sightings over the last several days reveals a sobering truth about Mozambique's manta ray population.
That's indicative of the fact that the populations are crashing. Mantas, we used to encounter them 80–90% of the time we would go diving, and now sometimes it's 30% of the time that we go diving. We've lost a lot of our animals here, so it's not as easy to have encounters with these giants anymore.
Andrea's concerned about her manta ray population, but she must press on with the task at hand: locating the small eye stingrays that come here seasonally. Today, Andrea's team will head south to continue the search. The visibility underwater will be poor, so finding the animals will be harder. But for researcher Claire Preble, the murky conditions here in Tofo are an advantage. Cloudy water is often created by nutrients. Plankton, the tiny plant and animal-based organisms that drift on the ocean's current, use these nutrients, along with sunlight, to grow. Plankton is the main food source of the animal Claire hopes to sight today, the whale shark.
One of the first and most important pieces of information that we like to get about the whale sharks is actually their identity. So the way that we do this is through a technique called photo identification. The spots and stripes make a wonderful fingerprint, really, for us to be able to identify individual sharks. The ID area is here, so we take a photograph behind the gills and next to the pectoral fin in this sort of square box here, just before it gets to the ridges. At the moment, in Mozambique, we have identified 665 sharks. We have a good idea of what the whale sharks are doing when they are close to this coastline. So the information that we're lacking at the moment is what these animals are doing and where they're spending their time when they're away from this coastal aggregation site. By looking at their diet, looking at their tissues, we can find out what they're eating, and from that we can also find out where they're eating. We do a couple of different types of analyses on this tissue, and it's based on a you are what you eat principle. As the whale sharks go through their life, they will, swim into different areas and they will eat different things. And this biochemical analysis we do is really just taking advantage of this tissue passport that the whale sharks have created unknowingly in their skin, and we can almost reverse engineer what they've been doing and where they've been going from this.
To collect a sample, researchers poke the whale shark with a pole spear rigged with a biopsy tip. They target an area near the dorsal fin, where the animal's skin is thickest and the density of nerve endings is lowest. This ensures the animal doesn't suffer. It's likely the whale shark doesn't even feel the poke. As the team heads out, Claire looks for whale sharks. But spotting them is no easy feat along this coastline.
Whale sharks don't actually spend very much time very close to the surface, so they're really just looking for a suspicious shark-looking shadow underwater.
So far, no whale sharks. So she turns her attention to another, less glamorous area of research.
We're going to do a tow now. This is the very large plankton net that we're going to use. It's got a very, very fine mesh, so we're going to get quite a lot of the zooplankton in the water.
Zooplankton are tiny aquatic animals, no larger than a grain of rice. From copepods to crustacean and snail larvae, these tiny creatures drift in the water, nourishing ocean filter feeders small and large. Zooplankton is a favorite food of whale sharks. These tiny animals could be the reason that the resident population of whale sharks remains along this coastline.
Plankton is actually quite dense at the moment, so I actually don't think we're going to need to tow for very long.
Without a microscope, zooplankton are nearly invisible.
This may look like regular drinking water to most people. It's an incredibly useful sample for me.
Claire sieves the water out.
We've got some small copepods in here. We've got a bit of gelatinous zooplankton as well. If we look at it, there's really not very much plankton on there, but that's more than enough for me to run 2 or 3 different types of analysis with it, so I'm pretty happy.
If the tissue sample from the whale shark matches these plankton samples, it will prove that Claire's sharks do in fact feed along this coastline.
Also today, one of the aims is to collect samples from jellyfish. There's quite a lot of jellyfish around here at the moment.
The diet of a jellyfish is similar to that of a whale shark. Both feed on tiny plankton that drift in the water. Jellyfish are short-lived creatures. They're also poor swimmers and rely largely on the current for transportation, making them a good representative of the local food web. Claire jumps in to grab a sample. She wears gloves to prevent a painful jellyfish sting.
What I like to do is take a bit of the bell, so around the edge of the domed part of the jellyfish. I really only need a small tissue sample.
Andrea and Anna are hopeful the plankton in these murky waters will invite some megafauna. And it has, but not in the way they hoped.
We're on our way to a dive site now, and we actually see the locals cutting up some really big animal on the beach. So I'm assuming it's a manta ray. We see a big gill net behind them, so it's obviously an animal that's probably run into a gill net, as it happens along this coast. We've lost a lot of our mantas as a result of that, a lot of our other megafauna, so it's really important for us to get an understanding of, what's being caught, how it's being caught, and where.
Let's go! Wave coming. So Andrea and Anna and Claire decided to swim through the waves to go and see what it is, to identify the animal before they chop it up and it's unidentifiable. I'm going to quickly fly the drone just to get some evidence also and to get a picture.
Photo and video evidence of this incident is crucial for Andrea and her team to convince the Mozambican government of the need for manta protection along this coastline. They head in for a closer look and to collect specimens from the dead ray.
So you can see they've just killed a manta on a beach. I think they probably caught it in that gill net. You can see all of its gill rakers here on the beach, part of its head. We've obviously identified this as a female manta. You can see actually here its eggs. It has some very quite mature eggs.
The death of a mature female manta ray is a huge loss. Most females don't reach sexual maturity until they're 10 years old. It's assumed that a healthy mother gives birth to just one pup every 2 to 5 years throughout her lifetime, which is thought to be 40 years.
It's a big problem for these large animals because they reproduce so slowly that they cannot withstand any sort of fishing pressure. By far, the biggest threat to our marine megafauna here are gill nets. Gill nets are set up by many different groups of people and villages up and down this entire coastline, and they're set perpendicular to the coast. So as these animals travel up and down the stretch of water that they're utilizing, they'll run straight into these gill nets. And the fishermen might be looking for smaller fish to eat for dinner, but if they catch a manta, most of these people, they're hungry, they don't have many options, and they're gonna eat whatever swims into that net.
The manta ray is now completely chopped to pieces. This is a meal for an entire village. For Andrea and Anna, it's a tragedy.
I've established such a close connection to these animals. They're not just mantas for me anymore. I want to know who it is. I want to know which manta's gone.
She scours the beach in search of any body part with spots, anything she can piece together to identify this manta ray. But it's hopeless.
It's like finding a friend. But at the same time, you know, I think it's really important to try and rise above that a bit and try and get a positive out of a negative.
Andrea and her team are able to take samples from the manta ray that will advance their research.
Luckily, we were able to secure almost all of the samples that we wanted, so we were able to do a lot of science, even though it's really obviously a sad thing to see.
With heavy hearts, the team heads back to shore. Down at Zavra, Nakia and her team encounter a sobering reality of their own.
Just as we were finished launching the boat, we were on our way just behind the breakers, and a fishing boat, a local fisherman came to us, and he said he has a problem. We got ready to go assess the situation.
A leatherback turtle's been caught in a gill net.
I think it's a leatherback turtle. It's a big leatherback on a net. Oh, big one.
Okay.
Yes, yes.
Oh, it's right there. Okay.
Oh, guys, it's a big leatherback. It's getting drowned now.
I was in a state of mind of just get in the water, get this turtle cut out, let it go free. No matter what happens, no matter the conditions, just dive down. When a turtle's in distress, they have about a range, about a few minutes of surviving time, because they lose a lot of oxygen when they stress.
It's a big turtle, and it's a really rare turtle to see. I haven't seen the leatherback right close to the beach, so this is my first time.
The team only has 10 minutes to save this endangered turtle. Nakia holds the leatherback still for Mornay.
And I was just cutting the net off, trying to free the turtle as quick as possible, but at the same time not cutting off parts that will make it swim away with netting around the neck or the flippers.
I don't know what's going to happen with the guys in the water now, so Pedro, can we go closer to see what's happening, please?
The turtle swims off, but a piece of netting is still tangled around her fin. Mornay chases after her. Finally, the team can breathe a sigh of relief. She is free.
It was entangled very, very badly, and luckily we were there to rescue it, but had we not been there, you know, it probably would have drowned. And it's sad to see these larger animals get entangled and die, just at the cost of these fishing practices.
It's not only one net, it's you can see it. It's a lot of boys. We have like 7, 10 nets at same place. So it's quite dangerous. They caught big mantas and big rays, a lot of rays and sharks and stuff. It's not legal. But yeah, our government tried to stop, but it's the local people. This is the food source.
Back in Tofo, Claire freezes her plankton and jellyfish samples to be sent off for analysis.
Once I've analyzed all of the data, this is the kind of graph that I get.
An overlap between the blue dots belonging to the whale sharks and the red dots belonging to other plankton-eating animals will prove that the whale sharks come here specifically to feed on the plankton.
So what I'll be looking for with the data in Mozambique is whether the whale sharks fall very, very close and very nicely within the species that we sample from this coastline.
Andrea's research is a little messier.
We just got back from the boat, and I'm trying to rush to get some of these samples processed. Obviously, nobody wants to see mantas get killed, so we're trying to make something good out of a bad situation. We got a bunch of things from the manta. We got a bit of the jaw so that we can have a look at the teeth, a bit of the gill raker. That's actually what people kill mantas for, is literally for the gill rakers to trade for Chinese tonics. We got a piece of liver. I mean, just endless amounts of little bits that we got from the manta. Very few biologists have the opportunity to be able to dissect mantas and collect parts from them. It's one of the biggest issues of trying to describe species is you actually don't have access to dead specimens. In order to document a species, you actually have to look at everything from their teeth to their skin to their gills. In the early days, I used to get quite upset and emotional, and now you have to just try and think to yourself, that manta's already gone. What can we get from this? You know, what information can we get from the locals to understand their perspective? What information can we get from the animals that can help further science so that we can figure out how to stop this? And that's what we did today. You know, it was very much business. We went in, we talked to the fishermen, we collected our samples, and we left. Later tonight, I might have a drink to that manta. But, you know, at the moment, we're still processing those samples and trying to get as much as we can so that wasn't a wasted life.
The next several days yield no sightings of small-eye stingrays, and more concerningly, no manta rays.
With small-eye stingrays, our studies are so new with them, we can't really give much good information on whether the population is increasing or decreasing. They are something that's quite uncommon to see, which is why we really have to integrate their research in opportunistically when we're studying mantas, because the mantas have historically been much more consistent in this area, whereas small eyes show up less frequently.
3 days after the camera crew left, a marine megafauna researcher filmed this sighting of a small-eye stingray. One of the ocean's most rare animals has been seen. But this coastline's most frequent visitors, the manta rays, are nowhere to be found, highlighting the problem.
We've seen more than 88% decline in sightings, which is the largest decline on record anywhere in the world. That's huge. A lot of that is due to fishing.
From Tofo Beach to Zavra Bay, the coast of Mozambique is under pressure. Gill nets snare the marine giants that call this coastline home. But the researchers that live here will stop at nothing to protect them.
It got under my skin, this place, these animals, so I'm really committed to this coastline now, and this is still my home, and I won't leave until I see this population is protected.
We've recently increased our conservation outreach into the local communities, working with local fishing collectives and cooperatives to implement more sustainable fishing methods and really have them manage their own resources.
Researchers here in Mozambique are targeting the creation of marine protected areas. And the way that we're doing that is we're trying to isolate what are the most important critical habitats along this coastline so that we can figure out how to protect them first.
The manta rays use a very close reef as a cleaning station. Turtles are using our beaches to nest on. So protecting these areas is very important in order to keep these species from declining any more than they already are.
The ocean really supports the life on this planet, and so we don't really have a choice but to fix some of these issues. Hopefully we can build a chain of parks along the coastline, maybe even connect those areas so that we can have a large enough marine protected area. It's only by working together that we're going to figure out how to save the ocean.